Today we will learn about semiconductor laser. Semiconductor laser, which is based on semiconductors. The development of semiconductor laser created a lot of revolution in electronics as compared to other type of laser, gas laser, solid laser. On one side, the efficiency is low and not easy to put carry out one plus to another or heavy component. This laser is very small in size and very good efficiency. As this is also the last topic of our unit, semiconductor laser types. In this lecture, we will be able to learn about principle, construction, working and applications of laser. Semiconductor laser play an important role in our everyday life. These lasers are cheap, compact size and consume low power semiconductor. This also known as laser diodes. Semiconductor laser basically are different from solid state laser. In solid state laser, light energy is used as the pumping source, whereas here the pumping mechanism is different. Here we use electrical energy as the pump source and we use the semiconductor diode method and biasing out the diode as a pumping source here. In semiconductor laser, a p-n junction of semiconductor diode forms the active medium or lasing medium. An optical gain is produced within semiconducting material. Semiconductor diode is specifically fabricated p-n junction diode. I think all of you are aware with p-n junction diode. On one side we have p-type semiconductor and on the other side we have n-type semiconductor. And junction is very useful. We have in the previous classes we have talked about many types of junctions. The diode emits laser light when it is in forward bias. So whenever it is asked what is the pumping mechanism, here we are pumping the system using forward biasing. This pumping is entirely different from other type of pumping that we have used in gas or solid laser. It is shown here a PN. When a PN junction is in forward bias, the electron from N and hole from P cross the junction, as we know. Here you can see this is in forward bias. We have forward bias means we have positive side of the battery is connected to the P and similarly N side to N. And due to this forwardness, electron will move toward junction and holes from P side move toward junction. This is forward biasing. On this side, you are observing that this is your valence band and the electron move whenever electron move from higher level to lower level, this gives us energy in terms of photons. Here on the right hand side you can see the p-n junction with energy levels. Whenever we join p-type with n-type, in p-type the Fermi level is close to valence band and in n-type close to conduction band. So whenever you join, then equalify this, then This behave as a p-type and n-type junction, and during the recombination process, the light radiation is released from a certain specified direct band gap semiconductor. This radiation is known as recombination radiation. Electrons have some energy, and these electrons join with the p-type semiconductor holes here in the junction. As electrons and holes move toward the junction. Now, the photon emitted during the recombination stimulates other electrons and holes to recombine. As a result, spin diffraction takes place. So, we use this method for creation of semiconductor laser. Here, it is to giving you the idea. The active medium is a P-N junction diode made from single crystal of gallium arsenide. The crystal cut into the form of platter form having thickness of 0.5 micrometer. And in this, as shown here, the lower part is N junction and upper is P, and there is a PN junction. We have used a metal contact here. This is on the upper electrode and the lower electrode. Now, the laser output comes from the sides on forward biasing. As these part consists of p-type and n-type, the photon emission is simulated in a thin layer of p-n junction, which is of the order of few microns. The electrical voltage is applied to crystal through electrode fixed and the upper surface. The end surface junction diodes are well polished and parallel to each other. They act as optical resonator and so give large number of photons having same amplitude, same frequency, and same state of polarization. When the PN junction is forward biased with large applied voltage, the electron and holes are injected into junction region. As we have seen in the previous slide, holes from the P side and electron from the N side. Now in the junction region, large amount will be there. Very high concentration is there, and the region around the junction contains large number of electrons in conduction band and large number of holes in valence band. They combine there. As the population density is very high in holes in are too much in valence band and electrons are too much in conduction band, a condition of population inversion achieved. The electron and hole combined with each other, and this recombination produces radiation in the form of light. When the forward bias is increased, more and more light photons are emitted and light production instantly becomes stronger. These photons will trigger a chain of simulated recombination resulting in release of photon in phase. The photon emitting at the plane of junction travel back and forth by the reflection between two parallel and opposite sides of each other and grow in strength. And after gaining the strength, it gives out a laser beam, normally in the wavelength of 8400 angstrom. The band gap is responsible for band wavelength, and this using this we can calculate the wavelength H over Eg. Whenever we study the semiconductor laser, we must know it has very extraordinary characteristics. Of course, it is a solid state semiconductor laser, and active medium in this is PN junction diode made from single crystal. Most of the time we use gallium arsenide. However, new type of materials also is in use now. We use a pumping method, that is direct conversion method, direct pumping and forward bias. The output we can achieve is of the order of 1 milliwatt. The nature of object output is continuous or pulse as we require, and the wavelength of output is about 8300 to 8500. And of course in red also. The biggest advantage of this laser kind of laser is it is very small in dimension, very small. Even with the case, it is about 5 centimeter or something. Without case, it is only less than 1 centimeter. The arrangement is simple and it exhibits high efficiency. The laser output can easily be increased by controlling the junction current. This is operated with less power than CO2. It is again an interesting thing. Very less other equipments are needed for this as needed in other type of laser. So that is why it's very small and handy. You can port it from one place to another easily in a pocket. It can have a continuous wave output or pulse output as per our requirement. However, it is difficult to control the mode pattern and mode structure of laser. The output is usually from 5 degree to 15 degree. Laser beam has large divergence as compared to other lasers. The purity and monochromaticity are power than other type of laser. So that is there, and why it is some kind of purity is not there and monochromaticity is not as compared to others, slightly lower than others. Threshold current intensity is about 4 ampere per mm square. It has poor coherence and poor stability. These are certain disadvantages, but for practical purpose, it has lot of advantages. It is widely used in fiber optic communication. It is also used to heal the wounds by infrared radiation. It is also used as a painkiller. Medical applications are there. It is used as laser printer and CD writing, reading. So many applications we are using. Thank you all. We have discussed here semiconductor laser. We already discussed my other lasers in the previous lectures, and this completes our unit task. Thank you.